In this video, I'm going to show you how to calculate certain probabilities associated with the binomial distribution using the calculator. And before I launch with the example that I'm going to do, a couple of thoughts. For one thing, it'd be a very good thing for you to study the technology step by step that's found on page 358 of the text very carefully. It's very clear and it tells you exactly what you need to know about using the calculator for this. Two, it wouldn't be a bad call for you to download the PowerPoints that I have for my face-to-face class, in particular the one that covers Chapter 6, and look at the section that covers Section 6.2. You can find some additional information there. Final thought before I launch with the example, it's very common to find students in Math 130 who, when they're working on problems from the text or they're working on online homework, something like that, can tell, okay, this is a problem that involves the binomial because it's from Section 6.2 or something like that. But when they encounter problems that are on the test that are stripped of context, they find that all of a sudden they're not very good at recognizing when the binomial can be applied. So you want to study those conditions that are listed in Section 6.2, the conditions that have to be satisfied in order to use the binomial model. Make sure you know those and make sure you know it when you see it, because we really want to make sure that you can field the problems that are stripped of context, like the ones on the test. You got to know when you can use the binomial and when you can't. And the mock exam should be very helpful in that respect. Now, I'm looking at page 355 of the text, and I'm going to do problem number 42 right there. It's called Broadband Video Consumers, and it says as follows. According to the report Broadband Content and Services 2007 by Horowitz Associates Incorporated, 6 out of 10 adult high-speed internet users watch online video content at least once per week. 20 adult high-speed internet users are randomly selected, and the number who watch online video content at least once per week is recorded. Now before we launch, there's a couple of things to pull out of the problem right there. First of all, 6 out of 10, that is P, the probability of success. So that would be 0.6. And also N, the number of trials, would be 20. So part A reads as follows. It says, find the probability that exactly 5 users watch online video content at least once per week. That is a binom PDF, a probability density function. We want to go to the distributions menu here. You can use the up arrow to get to that very quickly. How do we know that it's a binom PDF? Because they're asking for one value of x. They're asking specifically what's the probability that x, the binomial random variable, is equal to 5. And so we want to select that function right there. The syntax that this function requires is n, p, x. So in other words, the number of trials first, which here is 20. The probability of success, which is 0.7 or 0.6. And then the number of successes we're looking for, which in this case would be 5. And that's the result right there. Part B for the question is asking, find the probability that fewer than 8 users watch online video content at least once per week. And then they ask a follow-up question, would this be unusual? Let's answer the first question. It says, find the probability that fewer than 8. Now you got to understand the binomial is a discrete distribution, so fewer than 8 in this case. In other words, the probability that x is less than 8 is the same as the probability that x is less than or equal to 7. And so we're being asked here for several values of x. In other words, x is 0, 1, 2, 3, 4, 5, 6, 7. And so for multiple values of x, we need to use the binomial CDF, the cumulative density function. And so that's the one that's right below the PDF right there. So we'll select that. And the syntax for that is the same. So in this case, it would be 20, comma, 0.6, comma, and we're looking again for the probability that x is less than or equal to 7. And so there's the result right there. Now the follow-up question they ask, would this be unusual? What they are asking specifically is the probability you just obtained less than or equal to 0.05. And if it is, it makes it unusual. That's less than 1 in 20. So in this case, the probability we got was 0.02, and that is definitely less than 0.05. So that particular event would qualify as unlikely or unusual. Part C asks, find the probability that at least 15 users watch online video content at least once per week. Would this be unusual? Now this one is also a binomial CDF because again we're being asked for multiple values of the variable x. We're asked for x is 15, 16, 17, 18, 19, 20. Now you could calculate it directly, but the easiest way to calculate it would be to use the complement. And the complement of at least 15, which is probability that x is greater than or equal to 15, the complement of that would be x less than or equal to 14, because again this is a discrete distribution. So the best way to pull this off would be to take 1 and subtract the probability of the complement, which would be, in this case, binomial CDF and the syntax would be again 20, comma 0.6, comma 14. If you'd used 15 in this case, you'd be off slightly and the result would be wrong. So there's the result right there, and they ask, is this unusual or would this be unusual? The answer is no, because the probability is greater than 0.05. Part D says, find the probability that between 8 and 12 users inclusive watch online video content at least once per week. The best way to pull this off would be to use the binomial CDF, and we want to do two separate calculations and take the difference. So we're going to calculate the probability that x is less than or equal to 12, and then from that we're going to subtract the probability that x is less than or equal to 7. In order to get the 8 where we want it, we cannot subtract the probability that x is less than or equal to 8 because it would end up in the wrong part of the answer there. We want to make sure that we're subtracting the right portion of the distribution. So that would be x less than or equal to 7. So here's how you pull that off. You go to the distributions menu again, go to binomial CDF, and so the larger of the two probabilities will be the one that probability that x is less than or equal to 12. So that's the one we'll calculate first. So that would be 20, or well, sorry, keyed the wrong thing there. Go back to the distribution and get the one that I want. Binomial CDF, 20, comma, 0.6, comma, 12. That's the probability right there that x is less than or equal to 12. And from that I want to subtract the probability that x is less than or equal to 7. So I go back to the distribution menu, go back and get another copy of binomial CDF, press enter, and the syntax would here be 20, comma, 0.6, comma, 7. And there's the result right there. Final part, it says suppose 20 adult high-speed internet users are randomly selected and 17 report watching online video content at least once per week. Would it be unusual for 17 or more adult internet users to watch video content at least once per week? What might you conclude? Well, this is very similar to part C here. So we're going to get at this one using the complement. So we would take 1 minus, and the probability that x is greater than or equal to 17 would be the same as 1 minus the probability that x is less than or equal to 16. So that's the one we'll take. And so the syntax would be 20, comma, 0.6, comma, 16. And the result is right there. And again, they are asking, is that unusual? Well, it is, because the probability is less than 0.05. So I hope that'll be of help, and please make sure you study the mock exam that covers this very carefully.